Good evening. My name is David, and I'm here to talk a little bit about the importance of water testing and why it would be pertinent for really any location in any area. Now, I'm going to shed a light on where we're testing. So, we are testing at the Hayho Riverwalk. It's actually a stream just outside of Mason. And essentially, this is a local waterway in that area, and it provides not only drinking water for some of the animals in the area, but also provides some of the main aquifers that a lot of people get their drinking water from in that area. So it would definitely be pertinent for most people to not only understand what's in that water supply, but also manage it. So if we can see down here, you'll be able to see a picture of this is where I actually retrieve the water sample from. This is about midway between the start of the creek and the end of the creek there at the downtown area of Mason. And this is where most of the water, it expands quite a bit, and you'll see kind of a pickup of the current there. Um, Now, the water temperature, I tested these more in early spring, so it regardless of the day, it stayed relatively consistent within a few degrees of each other. As you can see, I have 11, 12, and again 12 degrees Celsius. So right around that same pocket, didn't really change or vary significantly during each of these tests. Now, the turbidity of the water here, now this has to do with how clear the water is. I retrieved most of these samples from closer to the bottom because I wanted to get a really nice sample of what could be not only flowing through the water, but also could what would be settling down in that sediment. You know, what could be settling there is the pH higher down there. So essentially, that's why we see a little bit more of a clouded sample here. Now, the turbidity here is obviously very high. It tested at a 100 JTU, which is essentially as high as it can go for this test. And that is due to the fact that most of this was taken from the very bottom of that stream. So the transparency is next to none, which doesn't really affect drinking water one way or another. You can always filter out those sediments if needed. Now, the next portion of this is far more important in terms of safety for drinking water. We have the coliform bacteria test. Now, as you can see here, this tested positive for the existence of bacteria, which tells us that there is a high amount of this bacteria in the water supply. Now, again, this is something that we can take action against, and we can take steps to prevent that having any sort of negative ramifications. However, it does exist, and this can be taken care of through simply boiling water or taking certain steps and chemicals added to the water to kill or mitigate that bacteria population. So as you can see, not a surprise, open water source, it did test positive. Now, next, we can talk about the dissolved oxygen. Now, when we did the dissolved oxygen test, we can tell that it tested relatively low. We have it as 4 ppm, which is essentially kind of midway, which isn't as low as it could be, but it certainly isn't as good as it could be either. Now, moving on to the next portion, we'll see why it was lower. It has to do with the nitrate or the nitrate amount that was tested within the water, and not having enough oxygen in the water can really affect not only the health of the water, but really it comes down to some of the creatures that live within that environment, especially if you're referring to the fish population and whatnot. So it's very important, and we're going to explain a little bit more as to why the nitrogen is really negatively affecting that and why this tells us this is an issue. So as we can see, the nitrogen test. Now, this is far higher, and what is driving that oxygen level down. We tested at 40 ppm, which is, again, as high as we can go in this test. And this is actually due to more than likely industrial runoff. Nitrogen is, there's actually a feeding mill upstream from this, and they use a lot of different chemicals to process most of the goods that they sell, and it causes potentially a fair amount of runoff into this local stream, and that's why we might be seeing such an elevated level of the nitrates in this system here. Now, generally speaking, in a natural area, this would be caused by dead plants, animals, maybe some excretions of animals releasing the nitrates into the aquatic system. Now, that's okay, but when this gets a little bit too high, it actually mitigates, like I said, the oxygen, And it can actually have negative effects on not only animals living in that environment, but also the human body. It can actually affect our body's ability to glean and take oxygen from the air, and that can obviously have negative effects on us as people. So this is certainly something that the general population should be aware of and should most likely take action against to ensure that they don't experience any of those negative ramifications. Now, next, we have the pH test. Now, as you can see here, it tested normal, relatively normal, an 8 on the pH scale. Now, anything less than a 7 is going to be acidic, and anything greater to even a 14 would be basic. Now, this tested as an 8, so this is far more on the basic side. And while that's still in relatively normal realm, it is far more on the basic side. And this again can be caused by potentially agricultural runoff and different things like that. So that tells us that, especially since there is the presence of industrial components in this area, that it's a safe assumption to say that this higher level of basic material could certainly, with driving up the nitrogen levels, could also be driving up those pH levels. So it's kind of not necessarily in and of itself a bad thing, but it definitely could give us a red flag as to what else could be going on, potential chemicals in the water supply, potentially things that could be negatively affecting the general population as well as the ecosystem. So it's certainly something to keep in mind. And now that brings us to our phosphate test. And we can see here that resulted at a 2 ppm for the phosphate test. And that's mild. It's not necessarily too high, not necessarily too low. And as we can see here, this is, excuse me, this, if it was too high, could result in less oxygen being taken into the water. However, like I said, this is mild. This isn't anything to be concerned with here. And any of the higher levels that we've seen here are not due to having any sort of minerals or organic material in the water. It has more to do with some of those chemicals that are sitting here. So the phosphate levels, very normal, very consistent, nothing to be too concerned with. However, with that being said, I would say that based off of these tests and what we've run here, and the fact that Mason uses this and it does feed a lot of the aquifers that we see here for the general population, I would say this water is not safe to drink. While it may not be the most dangerous thing in the world, I would say that it does present its own obstacles to overcome to ensure that the drinking water is safe. Because some of these things could potentially cause maybe not immediate negative effects, but over the long term could cause a lot of negative consequences for those that may be consuming this knowingly or unknowingly. So I'd certainly say that it'd be in their best interest to take action and clean and maintain the health of this water supply for as long as possible for those current and future generations. With that, I would like to say thank you for your time. I appreciate it. I'd like to open the floor at this point for any questions.